Okay, exponential and logarithmic equations. We are going to solve them. You've kind of already been doing it. These are just reminders. You don't need to write them. You know that ax plus by, or b to the x equals b to the y if and only if x equals y. We've already done the same bases. Yes, we get the same bases and the exponents are equal, correct? Mm-hmm. We've done that. So it also works with logarithms. So I have log base b and log base b. So the base is b, yes? That means the ofs are equal. So if you got them in the same base, then you can set them just equal to each other. That might make some things easy, right? This one you might want to write down. I guess you haven't had this one, have you?
What? The log?
Property of equality for logarithmic equation. You could just write this. Log base b of x equals log base b of b. If that is true, then x equals y. Bless you. I'm good? Mm-hmm. No, Austin usually starts after everyone's done.
Yeah.
Every time.
Also, how are you? I'm on time. Oh, my bad. I didn't know.
Okay, so we have exponentials, so our hope is we can get the same base, yes? We have 1/2 and we have 4. So what would be the base for both sides that we probably should try to get to?
2.
2. Okay, so I don't want 1/2, so how do I reciprocate something? What kind of an exponent do I use? What kind of exponent reciprocates? Negative. So this would be 2 to the negative x plus 7, wouldn't it? And 4 is to what?
2.
2 squared. So over here I get 6x. Mm-hmm. Now are my bases equal? Mm-hmm. So that means my exponents are what? Equal. So I have negative x plus 7 equals 6x. And now I just have a basic algebraic equation. What do you want to do first?
Minus the x. Distribute.
Okay, you can distribute or you can divide. Which one? You want to distribute? I personally would divide by -1. Myself? Why? Because then I don't have to distribute a negative, right? So I have x plus 7 equals -6. Now, could I have made it negative x minus 7 equals 6x? Could I have done that also?
Yeah.
Yes. The thing is, if I can divide by that -1, it makes it easier because you guys usually just say, oh, you got to distribute, but you get to the x and you stop, don't you? Okay, now what? Oh, I forgot my x, didn't I?
Yeah.
Now what?
Minus the x of it.
Okay, you guys solve it the way you would. Because at this point, you should be able to solve it. You got -1?
Yeah.
Okay. Okay. What about this one? Well, 25 is 5 squared, right?
Mm-hmm.
And 4 is
2 squared.
2 squared. So we can't get the same bases. Well, I got to get the variable out of the exponent. Is there a property somewhere that takes an exponent and gets it out of an exponent?
Nope.
No, you have to divide by 25. Isn't that something?
Mm. What about logs? What happens when you have an exponent with a logarithm? What's the exponent do?
Comes out.
It comes out, doesn't it? But I don't have a log. But could I take the log of both sides?
Yeah.
There's nothing that says as long as I do it to both sides, right? So you want natural log or log?
Log.
Log? Okay, because I can do either one. So we're going to have log of 25 to the x plus 7 equals log of 4 to the 3x. So our properties tell us in exponents that these go up front, don't they?
Yeah.
So that gives me 7 plus x times log of 25 equals 3x log of 4. We got them there. So we're solving for what?
X.
X. So what do we got to do to be able to get to the x's? Got the 3x. It's all good, right?
Mm-hmm.
What about the other one? Can you get the x out? Not unless you do what? What do parentheses mean, guys, with something next to it?
Multiply.
Multiply. So can I get to the x until do I have to multiply before I can get to that x?
Yeah.
Yeah, so I have to distribute this. Now you want to see why I said maybe we wanted to do natural log. So I have x log of 25 plus 7 log of 25 equals 3x log of 4. Now what? Guys, just because it looks funny, I'm doing no math that you haven't done before.
Minus 7 log of 25 over.
Okay, so you want to move this over here? Do we want to move this
no,
over?
Actually, the X.
You want to move the x, don't you? Good choice. So we're going to subtract the x over. So it gives me 7 log of 25 equals 3x log of 4 minus x log of 25. Now I got my x's to one side. My problem is I don't have just one of them. I have what?
2.
2. Well, if I have 2 terms that each have something in common, what can I do? What do we always do when something has, like, 2 things have something in common?
Divide by that thing.
Or factor it out, right? So can we factor out an x?
Yeah.
That would go from 2 x's to what? 1. And is that what we want? Okay. So that would be x 3 log of 4 minus log of 25. Okay. Now what? This is basically like 3x, isn't it? And if we're solving for x, then what do? Divide. So x is going to equal 7 log of 25 divided by this whole thing, isn't it? 3 log of 4 minus log of 25. Now, stop and look at the math that you did. Other than taking the log of both sides and doing your logarithmic properties, was that anything past Algebra 1? No. Just because it looks funny doesn't mean you guys don't know how to do it. And at this point, in order to get an answer, I'd put it in my calculator, wouldn't I?
Mm-hmm.
So if you took out your calculator, oh, can somebody tell me what it was? It was 7 log of 25.
Over 3 log of 4.
Okay, we need some calculators and some some parentheses in some places, don't we?
We got 23.970.
Ah. Okay, are there lots of parentheses involved here?
Yeah.
Yes. You got 23, approximately 24. Okay. You have to put your numerator in parentheses. You have to put the whole denominator in parentheses. It's important to know how to put things in your calculator, guys. Does everyone get that?
Mm-hmm.
Okay. Okay. 17 equals 4 to the x. Well, can I get... The first thing I want to do is get same bases. Because that's easy, right? Can I do that with this? No. So, I need to get to that x. So, it's an exponential form. I probably should put it into what?
Log.
Log. Or we could take... I'll show you two methods. Okay, so log base what?
17.
Nope. Base of the exponent is the base of the log. Log base 4 of 17 equals x.
Oh.
Yes?
Oh.
Now, can I put that in my calculator? No. You have to use change of base formula. What's the change of base formula?
Log of 17 divided by log of 4.
Okay, log of 17 divided by the log of 4. What's another way I could have done it? That's the common log. It's the other way.
Natural log.
And that is the...
Natural log of 17 divided by the natural log of 4.
And then you can put that in your calculator. Now, I want to show you how to do this. Without a calculator, this would be the answer you give me. This one or this one. Not this one. This one is not done. Got it? Okay, so I know I can't get the same base with 5x equals 12, can I? Nope. Remember the last problem we did? We took the log, not this one, but the one before. We took the log of both sides, right? Well, I'm going to take the natural log of both sides. Yeah? What's this x do? Comes out front, right? Look at that. Do I get the same answer basically?
Yeah.
Yeah. Could I have still done log base 5 of 12 equals x? So x equals log of 12 over log of 5? Either way. See how that works? There's multiple ways I can do that. Questions? I did it kind of fast because that goes kind of fast, right?
Yeah.
Do you think I could do that right away in every problem, or do I have to, like,
Simplify.
I have to simplify first, don't I? That exponent needs to be by itself, like nothing else going on with it. We good? Because they're just more examples. They just get more involved.
Are we doing more examples?
Yeah, see? They just get more involved. You want to be prepared, don't you?
Yeah.
Okay, 2 to the 3x equals 7 to the 7x. Was that the one that was on there? No. Oh, okay. How about this one? 3 to the x plus 1 equals 5 to the x. I didn't go back far enough, did I? So first of all, you always want to check for the one-to-one property. Can you get the same basis? Unfortunately not. So what do you want to do? Do you think just taking the natural log of both sides is going to be our easiest way to do it?
Yes.
Okay. And I'm going to just stick with natural log. We could do log, but natural log is only 2 letters, you know. So the natural log of 3. And what's going to happen to the x plus 1?
That'll go out.
Can we just skip to that? Is that going to bother anybody?
Might bother me,
It will bother you?
but I'm not writing it down.
Okay. You already took the other step.
Yeah.
And so the right side then would be what? X.
To the
Natural log of 5.
Yep, not to the, because that would be an exponent. So what do? I have this quantity. Don't forget parentheses around this quantity, because isn't the whole thing the exponent? Because if you forgot the parentheses, you wouldn't do the next step. What do we have to do? We have to distribute. And if you forgot those parentheses, would you distribute? Nope. So we have x natural log of 3 plus the natural log of 3. And you're just imitating success. What did we do the last time when we were in this situation? Look at the problem that we did.
We minus the x natural log of 3.
Okay, so natural log of 3 equals x natural log of 5 minus x natural log of 3. And Cole, what do we do next?
I don't know.
Look, do you have the last example written down? What do we do at that point? Austin, can you help him out?
Uh,
Who's
we have to put that in some way so we can put it in our calculator.
Right, we do.
Yeah.
Our problem is we have two x's, yes? And we have two terms with the same thing in them. What can we do? Factor. So I have x and natural log of 5 minus the natural log of 3. If you need to write on your notes, write. Factor out the x so you know when you go back and look at them. Because that's the whole point of these, right? Is to be able to reproduce. Okay, now that it's multiplication, I do what? Divide over. So x equals the natural log of 3 divided by the natural log of 5 minus the natural log of 3. And then to get an approximate answer, you'd stick that in your calculator. And honestly, I want you guys to be able to put them in your calculators, but the biggest thing is moving them around, right? So we changed forms, right?
Yeah.
Then we distributed. Distribute. And then we subtracted. Then we factor out an x. And then we divided. Were those basically the same steps we did on that other problem too? We switched forms, we distributed, we subtracted, we factored, we divided.
If you was to find the approximate.
You guys know that you have to put parentheses around the denominator, right? That's the biggest thing. I think we've all learned the cautionary tale of the lack of parentheses. Am I good?
Yeah.
Okay, you want to try this one on your own? I think so. I believe in you. Brandon, did you get that? What step did you forget to do? distribute, subtract, factor, or divide.
I got it.
Got it? And if you followed the form, switch forms, distribute, subtract, factor, divide. Yes?
Mm-hmm.
Gracie, you got it? Cole, did you get it? Yes, no, halfway?
Yeah.
Austin?
Yeah.
Cooper? No. Sam? Okay. Now we were in logarithmic, right? So we probably want to go to what? Exponential. So if the natural log of x squared minus 16 equals the natural log of 6x. Okay.
You wanted it to just be x squared minus 16
Well,
equals 6.
we're going to do something. We're going to take both of them and make them exponents.
What's
So it's e to the natural log of all that and e to the natural log of 6x. Now, what is the base of natural log? E. Okay, that's why I chose e. So when the base of the logarithm match the base of the exponent, the answer is just the what? Just the of. So it's x squared minus 16 equals 6x. Did everyone see what just happened? So if I had log base 7 of something equaled log base 7, or even, I'm just going to do it, equals 3, couldn't I make this 7 and this 7? So it would be whatever this is equals 7 to the third. No logarithm anymore. See how that works?
Yes.
And why did I pick 7? Because what?
Log base 7.
Log base 7. Okay, how do I solve x squared minus 16 equals 6x? Set it equal to 0. So x squared minus 6x minus 16 equals 0. And then you get to have fun. You think I'm just talking when I tell you factoring never goes away. Factors of 16 that have a difference of 6, 8 and 2, right? So x equals negative 2 and 8. Now, question though. A logarithmic function, when I graph it, it looks like this. Yes? What's its domain? What x's can I put in it? What x's are over here?
Positive.
Positive, right? So do we have to check and make sure our answers are going to give us a positive number?
Yeah.
Yeah.
No, we don't.
Yeah, we do.
We really don't.
So if I take negative 2 squared right here, that would be what? 4? Well, 4 minus 16 would be negative, wouldn't it?
Mm-hmm.
And if I put a negative 2 over here, it'd be negative. So is negative 2 going to work?
No.
Nope. Don't erase it. Just go like that. Now, is 8 going to work?
Yeah.
Yep, because it's going to be 64 minus 16, and then it's going to be positive. So that's called an extraneous solution. What does extraneous sound like? Extra.
I remember that one.
Yep, extraneous solutions. Okay, what are we going to do with this one?
And then back into exponential.
We're going to go from log to exponential. So I have log base 5 of x squared minus 45 equals log base 5 of 4x. What are we going to make those exponents of? What's my base? So 5 to the log base 5 of x squared minus 45, and 5 to the log base 5 of 4x. Can I do whatever I want to an equation? Yes, but
But
you have to do it to what? Both sides.
sides.
So, what do I get?
X squared minus 4x minus 45. Go back.
Yeah. And then Emma set it equal to 0 because I have a quadratic. So x squared minus 4x minus 45. And then I get to what? Your favoriteest thing to do. I like these all day. These are easy ones. Right? So x equals negative 5 and 9. Is negative 5 going to cause an issue?
Yes.
Yes. So
Negative.
this would be the easiest place to put it, right?
Yeah.
Doesn't have to be both. It just has to be only one not work. And it doesn't work. Does 9 work on both sides?
Yes.
Okay, so make sure you go and check for those extraneous solutions. I'm guilty of it too. I get going. I solve it. I'm having fun.
Fun.
Yeah.
What?
Yep. Am I good? Try this one on your own.
Oh, I forgot about the X thing. The giant X.
Alex, did you mess up somewhere?
How'd you get 2x plus 1?
Because 1 and 4, factors of 4 that add to 4, 2 and 2.
2 and 2.
So it'd be 2x plus 1 and 2x plus 1.
I put x plus 2, x plus 2.
Okay, but remember, this is the factors of A. And this is the factors of C. Right? Okay. So, is this negative 1/2 okay?
No. Wait.
Well, what's going to happen here? When you square a negative, it's going to become a positive, so it works there, right? What happens over here? A negative times a negative is a,
Positive.
and half of 4 is 2, so 2 is still bigger than 1, so does it work?
Yes.
You okay? Okay. So is the negative okay here? Yes. And I wanted this one to see because a lot of times people go, ooh, so no negatives? I can just cross out every negative answer? Can you just cross out every negative answer?
No.
No. Sometimes there will be 2 answers. Okay. 2x plus 1 to the 5th equals x minus 2. need to go back to log.
Brendan Salt, Tony Fernanda, and Dakota Whitman, please return back to Mrs. Sluter's room. Tony, Dakota, and
Should never.
Okay, so
They really just robbed it with me.
okay, so we need log.
Where'd it go?
We're going to have to do something with log. But we got that 5th there, don't we?
Yeah. Can't we just distribute them?
Well, no, we can't. Not when it's plus. I'm tempted to take the 5th rid of both sides. How about you guys?
Yeah. So I was like,
So take it to the 1/5. But that didn't help me either, did it?
Don't like
Well, let's see. So 2x plus 1 equals x minus 2 to the 1/5.
What are you gonna do with that one fit?
I know.
Heck no.
What did I do? I wonder if I put the... I wonder if I'm missing something. Maybe not. Maybe we just have to think harder. We want it to be easy, and it's not that easy yet.
I need it to be easy.
It needs to be easy. It can't always be easy. That'd be boring, wouldn't it?
no,
No,
it could
it'd be
easy.
amazing. Because then I know what I'm doing.
Oh, this one's a graphing one.
What?
That's a
Nope.
graphing
Next.
one.
Can we skip it?
Okay. So, you guys got it written down?
Yeah.
Okay. And then I'm going to write the next one down. I'm going to go for the next one. And we'll have you write that one down too, because I'm assuming it's a graphing one too. A graphing calculator? Yes. So write that one down.
Under the same one?
No, like different example. Like the last one was an example, this one. Because when I go to my calculator, you won't be able to see this. Right?
Okay.
I guess I could have side by side, but then the screens are too small and it's hard to see. Y'all got it down? Austin, let me know when you got it down.
Yeah, right there.
Okay. So let's get our calculators out. Okay. So when two equations are equal to each other, that means the graphs intersect, yes? So I can use my graphing portion to figure that out. Do you guys remember how to graph something?
Y equals.
Y equals. So go to y equals. Clear out your y's. And we're going to make the left-hand side of the equation one thing. And actually, there is supposed to be a log in front of that.
Log.
It's supposed to be log of 2x plus 1 to the 5th on your paper that you guys wrote. So log,
Does x minus 2 have one?
hello. Okay, bye. Log of 2x.
How do I do X?
There's a, right next to the green button, there's an x, t, theta, n. Okay, plus 1. And your parenthesis to the 5th. Okay, now go to y2 and put the right side.
So is there a log in front of that one?
No. That's just x minus 1.
2.
Or 2, sorry. Got both of those in there? Okay, so hit zoom 6 to get that 10 by 10 screen. And we're missing something, so we need over here more. We need over here more and over there less. So let's go to our window real quick. And I'm just going to tell you move that to 0 and move this to, no, 20.
No.
And then move your Y to 0 and 20. And then hit graph. You still do not see it all.
The FLA meeting today during senior high
Okay.
IAT in room 103. Be sure you report to your IAT first and then to the meeting. That's for FLA members.
Are you talking to me?
Yeah, you didn't put a 0 at 20.
Oh.
At the Y.
So do you see it all?
Yeah.
Okay.
Well, I see it currently.
No, we need to see more. Okay, we're not going to have time to see more. But there's... okay, so I can use intersect to do it. So if you have the calculator ones, we'll work on those tomorrow. I won't be here. I'll be at UNL with the juniors.
What the heck?
So you can do them all but the calculator ones. If you want to look in the book, it will show you how to use your calculator ones.